Have you ever wondered how OOPS concepts work in programming? Welcome to the fascinating world of object-oriented programming systems, commonly known as OOPS. This programming paradigm has revolutionized the way we approach software development, making it more intuitive and easier to manage. At its core, OOPS is all about objects. Imagine these objects as little self-contained units of code, each holding its own data and functions. But that's not all. There are 4 pillars that hold up the grand edifice of OOPS: encapsulation, inheritance, polymorphism, and abstraction. Encapsulation wraps code and data together into a single unit, protecting it from outside interference. Inheritance allows us to create new classes that share the properties of existing ones. Polymorphism gives us the flexibility to use one interface for a whole lot of different underlying forms. And lastly, abstraction simplifies complex systems by letting us focus on the essential features. Let's dive deeper into each of these concepts to understand them better. Imagine you're at a coffee shop, ordering a latte. You tell the barista your order, maybe specify the type of milk you want, and perhaps ask for a dash of cinnamon on top. But once your order is placed, the actual process of making your coffee is out of your hands and hidden from your view. This scenario is a great way to understand the concept of encapsulation in object-oriented programming. The barista in this case can be thought of as a class. Your order, with all its specifics, is the data. And the process of making the coffee, that's the method. Just like the barista doesn't need you to tell them how to steam the milk or pull the perfect shot of espresso, a class in programming doesn't need other parts of the program to know how it processes its data. The class takes in the data, works on it internally using its own methods, and then presents the final result. The whole process of how the data is handled is kept hidden from the outside world. This hiding of data and methods within the class is what we call encapsulation. It's like a protective barrier that prevents the data from being accessed directly from outside the class. You can think of it as the counter of the coffee shop, separating the customer from the chaos of coffee making. But why is this important, you might wonder? Well, encapsulation increases security and flexibility. It keeps the data safe from accidental changes and makes the program easier to manage, as each class is responsible for its own data and methods. So, in the same way, the barista encapsulates the process of making your coffee, keeping you from messing up the espresso machine or scalding yourself with steamed milk. Encapsulation in programming hides the data from being accessed directly. It ensures that the data is handled securely and correctly, preventing accidental mishaps and keeping your program running smoothly. Think about how children inherit traits from their parents. Now, let's transport this concept into the world of programming. In the realm of object-oriented programming, we have a similar relationship, a lineage, if you will, between classes. Just as children inherit traits from their parents, a class, also known as a child class, can inherit features from another class, the parent class. Let's delve a bit deeper. Imagine a family tree. At the top, you have the grandparents, then their children, and finally, the grandchildren. Each generation inherits characteristics from the previous one. Similarly, in programming, we can create a hierarchy of classes where a child class inherits properties and methods from its parent class. This inheritance isn't merely about obtaining features. It's about building upon existing structures, improving them, and making them more specific. For instance, a parent class could be something general like animal, with child classes bird and mammal inheriting from it. These child classes in turn can have their own child classes, such as eagle or dolphin, each inheriting and expanding on the traits of their parents. Now, why is this important? Well, inheritance is a powerful tool for 2 main reasons. First, it allows for the reuse of code. Instead of writing the same code repeatedly, we can write a method once in a parent class and let the child classes inherit it. This helps keep our code dry, which stands for don't repeat yourself. Secondly, inheritance establishes a relationship between classes, creating a clear, organized structure. This hierarchy can make it easier to understand how different classes are related and how they interact with each other. In conclusion, inheritance is like the DNA of programming. It's a way of passing down characteristics from parent to child, making our code more efficient, organized, and intuitive. So, the next time you see a family tree, think of the marvelous world of inheritance in programming. Inheritance allows developers to reuse the code and establish a relationship between different classes. Ever noticed how one object can take on many forms? Let's consider a person. This person, let's call him Raj, can be seen in multiple roles throughout his day. At work, Raj is a diligent software engineer, writing impeccable code and solving complex problems. When he gets home, he morphs into a loving dad, playing with his kids and helping them with their homework. And if you catch Raj at a party, you'll see him as a charming conversationalist, regaling his friends with interesting stories and witty jokes. This capability of Raj to adapt his behavior according to the situation is a lot like polymorphism in object-oriented programming. Polymorphism, a term derived from Greek words poly meaning many and morph meaning forms, is the ability of an object to take on many forms. In the programming world, an object like Raj could be a single variable or function or an object, which, akin to our friend Raj, behaves differently in different situations. It's like having a single interface with multiple functionalities. The behavior of the object isn't determined until it's run during the program, which is why polymorphism is also known as dynamic or late binding. Polymorphism has a couple of key benefits. First, it makes the code more flexible. Just as Raj can adapt to different situations, a polymorphic object can adapt to different requirements. This adaptability makes the code more versatile and easier to manage. Second, it enhances code reusability. Let's say you've written a function that can take on multiple forms. You can use that same function in different parts of your program, each time with a slightly different behavior. That's like getting multiple uses out of a single piece of code. So, just as Raj, the software engineer, the dad, and the partygoer is still Raj, a single object in your code can take on multiple roles thanks to the magic of polymorphism. Polymorphism enhances the flexibility and reusability of the code. Ever used a remote to change channels on your TV? Let's think about it. When you're lounging on your couch, remote in hand, ready to flip through the channels, do you ever stop to think about the intricate processes that occur when you press a button? Probably not. And why should you? As a user, your main concern is knowing which buttons to press to change the channel or adjust the volume. This is an everyday example of abstraction, a fundamental concept in object-oriented programming. Just like you don't need to know how your TV processes the signals from your remote in programming, you don't need to know the intricate details of how a piece of code functions to use it. What you do need to know are the essential details, the operations you can perform with that code. This is where abstraction comes into play. It hides the complex, nitty-gritty details and shows only what is necessary for the user. Let's imagine a class in a program as a TV. This class has various methods, similar to how a TV has different functions like changing channels, adjusting volume, or switching to a different input source. As a user, or in programming terms, a client of the class, you don't need to know how these methods are implemented. You only need to know what they do. The beauty of abstraction is that it allows you to focus on what the code does, not how it does it. It provides a way to reduce complexity and isolate impacts of changes. If a method in a class changes, but the way you use it doesn't, it's abstraction at work. In conclusion, abstraction is like a magic trick. It allows you to enjoy the spectacle without revealing how the trick is performed. It's a way to simplify complex systems by exposing only the necessary details. It's a key player in the world of object-oriented programming, making our lives as programmers easier and more efficient. Abstraction simplifies complex systems by exposing only the necessary details. So, we've explored the four main concepts of OOPS. Indeed, we've taken a deep dive into the world of object-oriented programming today. We've unpacked encapsulation, a concept that helps us safeguard our data, making sure it's only accessible where it's needed. We've also examined inheritance, a principle that allows us to create new classes from existing ones, promoting code reusability and reducing redundancy. Next, we ventured into the realm of polymorphism, a concept that enables us to interact with many data types and classes through a single interface, increasing flexibility in our code. Lastly, we delved into abstraction, a principle that lets us hide complex details and provide simpler interfaces, making our code easier to understand and use. These concepts, when combined, create a powerful toolset that can make your programming more efficient and manageable. They are the building blocks of a well-structured, scalable, and maintainable codebase. Understanding these OOPS concepts will pave the way for you to become a more efficient and effective programmer.